The decorator pattern lets you wrap objects with additional functionality at runtime, instead of baking everything into your class hierarchy. By the end, you'll know exactly why inheritance leads to explosion problems, how decorators solve it, and you'll see concrete code showing how to build them from a base component. Think of it like adding toppings to a coffee. Each decorator wraps the previous one, adding its own behavior without changing what's underneath. Picture a coffee shop application where you've got different coffee types: espresso, decaf, dark roast, and customers can add milk, mocha, whipped cream, whatever they want. If you try solving this with inheritance, you end up creating a separate class for every possible combination. Espresso with milk becomes one class. Espresso with milk and mocha becomes another. Add just 5 toppings, and suddenly you're maintaining dozens or even hundreds of classes. This is the class explosion problem. The decorator pattern solves this by wrapping your base object with decorator objects at runtime. Want an espresso with milk? Start with an espresso object, wrap it in a milk decorator. Add mocha? Wrap that whole thing in a mocha decorator. Each wrapper adds its own behavior and cost, and you can stack them in any combination you need. It's composition over inheritance. You're building up functionality piece by piece, giving you way more flexibility than locking everything in at compile time. Here's how the mechanics work. You've got a component interface that defines what operations your objects can do, like getCost or getDescription. Then there's your concrete component, which is just your base object, like simple coffee. Here's the key. Decorators also implement that same component interface, but they hold a reference to another component inside them. When you call getCost on a milk decorator, it calls getCost on whatever it's wrapping, adds its own cost, and returns the total. Each layer delegates to the one beneath it and adds its own twist. Let's see this in code. First, we define our component interface, coffee, with 2 methods, cost and description. Then we've got simple coffee, our concrete component. It returns $2 for the cost and a simple description. This is the object we'll be wrapping. Think of it as the core, the thing that actually does work. Everything else we build is going to wrap around this, adding features without touching this class at all. Now here's where it gets interesting. We create an abstract coffee decorator that wraps any coffee object. Notice the constructor. It takes a coffee and stores it. This is the wrapping in action. Then our concrete decorator, milk decorator, extends that base. When you call cost, it delegates to the wrapped coffee, adds 50 cents, and returns the total. Same with description. It calls through, then appends its own bit. We're enhancing behavior by wrapping and delegating, not by inheritance. Each decorator is lightweight, focused, and composable. Watch how this pattern shines in action. We add a mocha decorator, same structure, different behavior. 70 cents, adds mocha to the description. Start with simple coffee, $2. Wrap it with milk decorator, now it's $2.50. Wrap that result with mocha decorator, $3.20. Each wrapper adds its piece without knowing or caring what's inside. No explosion of subclasses, no rigid hierarchy. Just objects wrapping objects, stacking behavior like layers. This is composition at its finest, flexible, testable, and infinitely extensible. You've probably used this pattern without realizing it. Java's I/O streams. Classic decorator. Wrap a file input stream with buffered input stream to add buffering behavior. Express middleware. Each handler wraps the next, layering authentication, logging, validation. React's higher-order components. Same idea. Wrap your component to inject auth checks or logging. The pattern is everywhere because the problem is universal. We need to add responsibilities to objects without touching their code. Once you see it, you'll spot it in every mature codebase. Here's why decorators beat inheritance. With inheritance, you're locked in at compile time. Your class hierarchy is set in stone. Decorators let you compose behavior on the fly at runtime. Need logging today but not tomorrow? Just unwrap it. Inheritance forces you into rigid structures and that dreaded class explosion. Decorators give you Lego blocks. Snap them together however you need. Your codebase stays maintainable instead of spawning hundreds of subclasses. When should you reach for decorators? Anytime you're adding features dynamically, think permissions, caching, logging. They're perfect when you'd otherwise create 20 subclasses for every combination. But here's the catch. If the order matters and breaks things, like encryption must come before compression, you've got a problem. Same goes if you need to unwrap one specific decorator buried in the middle of your stack. And watch that wrapper depth. 10 decorators deep turns debugging into a nightmare. The decorator pattern is your escape hatch from inheritance hell. You're wrapping objects at runtime instead of locking yourself into rigid class hierarchies at compile time. Java's entire I/O library runs on this. Buffered reader, wrapping file reader, wrapping input stream reader. That's decorators in action. So next time you're about to spin up yet another subclass just to add one more feature, stop. Ask yourself if a decorator solves it cleaner. And if you want to see another pattern that'll save you from legacy code nightmares, check out my deep dive on the Strangler Fig pattern. It's how you modernize systems without the big rewrite.